Hi everyone. In this tutorial, we will talk some more advanced probability theories. So let's take an example. I have 10 coins. So 10 coins, and then each coin. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right? And then each coin can have head or a tail. So if can ask you to throw all this or flip all this 10 coins and tell me what are the possible number of ways this 10 coins can take head or tails. So for example, it can be head, tail, tail, head, head, tail, tail, head, tail, head, right? So this is like one case. So how many cases could be possible if you flip the coin and there are two options for each coin? So it sounds little difficult, but if you can look logically, so for each coin we have two cases, head or tail. So we will say 2, and then we multiply by 2 because other coin also has two option, and then we keep them multiplying 10 times. So that will be equal to 2 raised to power 10, and that is your answer. So we have 2 raised to power 10 as the number of possible ways these coins can flip and take head or tails. Another example, suppose you have a number lock. So, and you have four numbers on it, and each number could be from 0 to 9. So we'll say that what are the possible number of combinations this number lock can have. So if you want to, if you forget the your code for this lock, then what will be the probability that you give it a one try and you will be able to open it? So let's calculate it. So for each number we have 10 options, because we have 0 also, that's why we'll have 10 options for each number. And then for the second number we again have 10 options, third number we have 10 options, and fourth number we have 10 options. So the total will be 10 raised to power 4. So you have 10,000 possible ways in which this combination can be there. And if you forget your code, then if you try it once, the probability that you can open it will be very very low, and that will be equal to 1 divided by 10,000. So now let's take another example. In this case, I say that I have 10 guests and I want them to sit on the chairs. So this is chair number 1, chair number 2, 1, 2, and then similarly we have 10 chairs. And I want to sit them on the chairs. And I will ask, what are the possible number of ways that this 10 guests can sit on these chairs? And you will most likely will go back to the same approach, and will you say it will be 10 raised to power 10, but that is not correct. So why? That is because if a guest sit for the first chair, chair number 1, we have 10 options because any of the guests can sit on the first chair. But if you look at the second chair, we only have 9 guests left because one of the guests has already sitting on the first chair, and so we have 9 guests left, and therefore the option for the second chair will be 9. So it doesn't matter that the first uh, seat should be the first number, it could be any number, but suppose the first guest sit on the seat number 3, then for the next seat the option will be only 9 left. So if you go to the third chair, so we have already two guests who are already have sitting, so we have 8 left. And similarly we will, in the end, for the 10th chair we will only have one option left, so only one guest left. So therefore the number of possible ways will be 10 into 9 into 8 up to 1, and we can also call it as this number. So this is the number of possible ways. So it is very important that you can differentiate between these two different cases, in which in one case there is always the same number of available options. Another case they are limited, the number of option goes down as you go to the next possibility. For example, now let's take another example, and I say that we have 5 kids, and each kid can wear red or blue in class. So what are the number of possible ways that they can dress? So in this case we are saying that anyone can dress in red or anyone can dress in blue. So there is no we don't have like, if somebody dress in red and the other one doesn't, there is no restriction on the other one that he can also wear red or blue. So in this case the answer will be 2 raised to power 5. So we have two option for every kid. So please remember that it will be 2 raised to power 5, not 5 raised to power 2, because that will be incorrect. Because so for each kid we have two options. So 2 for each kid, so 2 into 2 into 2 into 2 into 2. Okay, and now let's go to another example. So we have uh, 3 kids, and we want them to stand in a queue. So they will stand 1, 2 and 3, so they will stand in a queue. And I want to know that what can be the different orders, or how many type of arrangements are possible. So in this case, if a kid, so for the first kid in the row we have 3 options, and then for the second position we already have first kid, so we only have 2, and then only have one option left, so that will be equal to 6 arrangements. So the kid can sit or stand in a queue in around 6 type of arrangement. So we can say again it as a 3, or that is equal to this thing. So now let's take another example. For example, um, I have one prize and I want to give it to one of the 50 kids. So what are the options? So my options will be 50. So I can give one prize to 50, one prize to 50 kids. So I can give it in 50 different ways. So because each kid will have one option, so it will be 50. However, if we have two prizes, then how many ways I can give this prize to the kid? So in that case, the first prize can be given to 50 kids, and for the second prize, because we already given the first prize to the first kid, so the other option will be 49 kids left, so that will be 50 into 49. So in this case we will have 50 into 49 is 2450. So that will be the number of options or number of ways. So this is again a different approach. So if you have 3 prices, then that will be equal to 50 into 49 into 48. But now as you can see that if I say the condition that every kid kid can win any number of prizes. So you look at this number, say any number of prizes. So for first prize we have 50 options, and then for the second prize, because the first kid has already win the prize but he can win it again, so again we have 50 options again. And for the third prize we have 50 options again, so we'll have 50 50 cube as our answer. So the only difference was that in the previous one a kid cannot win a prize again, but in this case a kid can win more than one prize, so that will give us a different answer. So this was some basic probability theory. So we'll discuss more advanced topics and try to solve some equations or more difficult probability questions in next tutorial. Thank you.